Hello.
Hi.
So the Node team is coming to learn about testing in Nearcore.
It's not for you guys. It's definitely not for you, Nikolai. You're gonna be super bored with this.
I have no idea about NADAC.
I am not gonna talk a lot about NADAC. We are killing it.
It's in the title. It says releases CI and NADAC.
Yeah, it's just suggestion.
Okay.
Yeah, I was thinking a lot about what I want to talk about, and then I started writing it down, and it took me an hour to write all of the things I want to cover. And I thought, well, I should maybe just cover the basics. I wanted to talk about how to write integration tests, like what basic integration tests we have, what basic PyTests we have, because it's super useful and it's super scary to do on your own. But
Why is it scary? It's a nice Python script.
okay. Um. Okay. Maybe we should wait for another minute and then we shall start. Václav, did you write any Rust integration tests, like tests in integration tests directory of Nearcore?
Yeah, I think one. Why? But a long time ago.
Was it scary for the first time user or no?
It wasn't too bad.
Yeah.
I mean, I copy pasted another test and changed it to do what I do. So.
Usual stuff. Okay, so let's start. Hi. I will cover some testing we do in Nearcore as part of continuous integration, as part of making sure that we are releasing good enough binaries and we are releasing good enough versions of our code. And it's gonna cover some technology, and mainly I'm gonna focus on the basics, and in the end I'm gonna tell you what you should know about testing in general after this presentation. So let's first think about the path from zero to mainnet, like from developing of your code to this code being run in mainnet on all of the nodes. So first, you write your code and test for your code, and you make sure your test pass in whatever order, doesn't matter. You would want to call cargo formats because it is part of the test. Your build guide will not be happy if your code is not formatted properly. If it's not an intuitive part of your pipeline to call this command, please include it in your workflow. But still, you commit, you push, you already know this part, you experienced it, it is easy. After that, you may have noticed that something called build guide creates a test run for your commit. Build guide generally configured to create a run for every new latest commit in the branch. And if the previous run hasn't finished and you pushed a new commit, the previous run will be dropped and the new run will be started for the new latest commit. This build guide run is running testing commands. Build guide is generally a tool that we use to run any commands on some cloud machines. We use it for two things: to run tests and to release binaries. Release is a tricky word. We use it like in 3 different minutes throughout the whole testing releasing process. Here, I mean releasing binaries as in compiling binaries and uploading them to S3. So build guide in our infrastructure does these two things. It tests our code and it publishes binaries. So build guide will create a test run for your commit. After that, you can see that probably your tests are green. You open your PR, then you go through iterations of improvements. For every new commit, build guide will again create a new test run. You approve, you merge, and you stop caring about your code. You move on to the next thing. But after that, testing doesn't stop. What happens after merge? At night, probably by some time zone, head of master will be tested on NADAC with more tests. NADAC is another testing system. It is created by us and it is maintained by us, and we are trying to kill it for that specific reason. On NADAC, we run more expensive tests that require more time to complete, and also fuzzing, which we will not cover here. Next day after your code was merged to master, the head of master is deployed to our canary nodes. It is a specific kind of nodes that we use for testing, and that code is also deployed to BetaNet, specific networks that we use for testing. I will cover them in detail later. And somewhere next month after your code was pushed to master, it will end up in the release branch that will be cut from master head. So from that point, your code is on the path to be definitely released. What happens between cutting the release branch and releasing on mainnet? So cutting the release branch is still action kind of visible to everybody, but ignored by everybody. It is only meaningful to us. We are cutting the release branch to kind of make sure that we are set the commits that we want to release and made this decision sort of final. No new features, no new commits from master will automatically end up in the release. We can cherry pick them into that branch, but it is a manual process where you need to contact node team if you want your feature to as soon as possible end up on the mainnet. After we cut the branch, after we settled on the commit that we want to release, we make sure that this commit is actually good. We do some testing. We do a testing via mocknet. So we are creating a mocknet and running some special code there to make sure that our new binary will be okay. And we, after that, after a week of waiting, the week, because we want to make sure that that code is also was tested on canaries, on BetaNet, and manually on mocknet, we are releasing it to testnet. Then comes iterations of improvements, because no release is perfect. There are always some new patches, but for every new release, we are creating a specific mocknet test. Somewhere after 3 weeks on testnet, I am not sure on this date, it is always sliding, but somewhere after 3 weeks on testnet, we release the branch to mainnet, and that's it. Your code is now in mainnet. So the whole process from coding to releasing on mainnet can take somewhere from a week in like very major security patch cases, or a few days in major security patch cases, to like 2 months. In case you just miss the release, you have to wait a month for testnet release, and then kind of a month for mainnet release. Okay, now I dropped a lot of words that you may not understand. Let's go through them. First word is build guide. What is build guide? First of all, build guide test pipeline is kind of a separate thing to what we use build guide regularly for. Mostly we use build guide by the number of scripts. We mostly use build guide for publishing binaries. But we also have build guide test pipeline. And you can find specification of that pipeline in Nearcore in this path. So there are clearly defined steps of testing. Mainly, you should be interested in cargo tests, so Rust tests. We are running inexpensive tests, so tests that weren't marked expensive and tests that weren't marked ignored. And we are running them with both stable and nightly build. And to speed things up, we are running them in batches. So we're separating integration tests, like a specific directory integration tests, and all the other tests. And we are also running some tests that are written in Python. The three last lines are Python tests, backwards compatible, upgradable, and DB migration. They're basically making sure that newest binary is compatible with latest release, that we can move from latest release to this commit. Also, there are some sanity checks for code. You probably noticed. That's why cargo format. Build guide test pipeline is called automatically for every latest commit in a branch. So to trigger it, you just have to push your code. And it is super easy. You have to wait 10 minutes and you will have results. It is longer to do all of this testing on your machine. So just push your code. But build guide is also used for other things. Oh, yeah, troubleshooting. Usually you want to see this green stuff, but sometimes it's not that. First thing you have to do is like sanity check that you're looking at the right page. I want to explain some things about this page. So you can see here at the top, you see the number of builds, but you can see also the name of the branch from which this build was pulled and a specific commit. You can click on it and go to the page. And the name of the build will be the name of the commit. So make sure that it is actually like correct commit that you want to test. Then you can also hit retry, like rebuild the whole thing from scratch. I don't know why you want to do that. Maybe there are major build guide problems like we're experiencing now, and they just fix them, and you can now click rebuild to make sure that your test is actually tested properly. But in other cases, you probably see that only one of those steps is failing because of flaky tests. Usually you can see that here you can see that I retried this test. You will see somewhere in this place a button to retry. If you don't see it, please log in. If you log in and don't see it, contact somebody from SRE team. Someone messed up with permissions. And how to make sure that it is actually a flaky test and not just your code introducing some bug. Well, you can expand commands, jump to the end, and then see specific tests that were failed. So here, kind of in the cyan color, you see the name of the tests that failed. I know that this test has nothing to do with my code, just from looking at the name. So I hit retry, and as it turns out, the test was just flaky. In this case, you should also notify someone in Zulip, or not if you're lazy, but probably should notify somebody in Zulip that you found another flaky test, and link this build guide build. If after retry you still find yourself with the same test failing, you always can rerun this specific test. So just don't forget to get in the guts of the commands. It is a tricky thing, so you can always look at the name of the test in GitHub and look at the blame who wrote this test, but that person might be already not working in Pagoda, and usually the tests that are flaky are very old, and so you just notify general, and maybe if the test is persistently flaky or nobody is responding, ping the whole core team or node team, just be bold with it. People usually are glad to fix flaky tests because it's easy, usually. Okay. If you ever merged code in master and also hovered over that green check mark near your commit, you may have noticed that there's a bunch of checks performed for your commit, a lot more than just for your commit in PR, like 9 checks compared to 2. It's because most of those checks are not checks. Those are builds. and specifically build kite builds. So you can see the suffix release, like Nearcore nightly release, Nearcore perf release, Nearcore release. These are jobs that are triggered on any master commit, and they're building a binary and releasing it to S3, publishing it to S3. They're also doing other stuff, but I don't know who uses that other stuff, and you may find binaries useful, so I'm only going to talk about them. So on master, it is happening automatically. The pipeline sort of looks like this. It has 4 combined steps, like 3 combined steps. Fetch pipeline doesn't count. And after all of those steps are completed, we are updating the latest version on S3. So how S3, what is S3? S3, you can think about as basically a file manager that is on the cloud and open to the public. We have a nice tree structure there, and your build will end up in a subdirectory Linux, subdirectory branch, your branch name, subdirectory your commit. So all of the commits related to master will end up in a Linux master. All commits related to specific release will end up in Linux and number of that release, because that's how we name branches for releases. And for that specific release, we will update the latest commits that we pushed to always kind of know what is the freshest binary for that specific branch. That is why you can also call this pipeline for your special branches that are not master. You can manually in the interface create a new build, give it arbitrary name, choose a commit that you want to build from, and choose a branch that you want to build from. This is basically creates a publicly available build on S3. It is useful in case you want to do some big testing, like with mocknet. You will need to make a binary downloadable by those nodes. Or if you want, in any case, in any way, publish a binary, this is the easiest way to do this. Or if you are lazy and don't want to wait for 30 minutes for build from zero on your new machine, I don't know. Yes.
If you're building on, as we were advised, on your fork, I believe BuildKite is not available. How do you publish? Can you still use BuildKite to publish a binary?
No, I don't think that this works for forks. So it is kind of a privilege for people who are in the Near organization, and it may go away. It is still a useful tool for Near release. So, and we use it for Near releases. So releases are still branches in the Nearcore repository, and for releases it is likely it is going to stay that way, that we are using BuildKite to build and release binaries. So if you ever want to check out a release that is not the latest but older, you can search through builds in BuildKite, or you can search directly through S3 directory, like Linux and version of the release that you want to check out. The binary is likely there. Again, if you are too lazy to build, and you should be, it takes too much time. Okay, so if you are confused where your binary ends up, you go to binary release step, you expand running commands, you jump to the end, and you see the whole wall of files being uploaded to S3 multiple times to multiple paths, just for the fun of it, for us to easily use it. But at the top, you will see that for 130.1 release, the neard was uploaded to that path, like Nearcore Linux 130.1 neard. And for like latest master, you will be finding neard in Nearcore Linux master neard. Easy. Just explaining some very basic stuff here. Okay. Also, you can look what update latest version does, and at the bottom you will see that it again updates latest file in the dir very specific to your branch. So if you are developing in Nearcore branches, not in forks, don't be afraid to build your specific binaries. It will not mess anything up. It will be just your little secret, your easy way to use your binary on other machines. Okay, let's move to NADAC. NADAC is something made by us, is something maintained by us, and something that we are soon gonna kill in order to make our lives easier, but also in order to use BuildKite more, because one instrument is better than two. NADAC is a system, is an orchestration system. So basically, we have a lot of machines, not a lot, but some machines in Google Cloud that we use specifically to run tests and fuzzing tests. And we call this in NADAC. NADAC runs tests specified in this file, and they are, for some reason, split into three categories and not in two: sandbox, PyTest, and expensive Rust tests. Sandbox tests, for purposes of this meeting, does not differ from PyTests. They are still PyTests that spin up local net and test some stuff. So you should know about two types of tests that we run on NADAC. First type of tests is Python tests that usually just create a local net environment, usually with 4 machines, and do any kind of testing that you want to do with a network. Some tests use different binaries on different nodes. Some tests upgrade database. Some tests kill one of the machines to make sure that that machine is banned, that node is banned as validator in the next epoch. All kinds of stuff. And expensive Rust tests are run also in NADAC because we cannot afford to run them per commit. It's way too long. So they are run nightly. As a user, you may see some context around any failed test. For Rust tests, I didn't include screenshot because it's trivial. It's just two outputs, error and regular output, for cargo test command. But for Python tests, it is a more trickier context. So Python tests, again, usually spin up a local net. So we need not only an output of specific Python file, like a Python run, we also need logs from those machines, and they can be found in test 0, test 1, and so on. And also, in order to debug this test, we probably would need a home directory of those nodes, and they can be found in node states. Those directories include everything: node keys, validator keys, if everything, configuration file, anything saved in that directory during the run. So if you run other command and just saved output there, it will be saved in the context, and you can look at later when the test fails. And also that DB directory, it is very useful if you want to kind of not recreate the test, but recreate the failure locally. But there are no silver bullet here, because how you should approach this heavily depends on the test. You should just know that you can access the full state of every node in your local net cluster after the test failed. If it didn't fail, I think we save only outputs, and we do not save home states of every node. As a developer, you can use it to make sure that your new big feature is not breaking anything that is not tested in build guide, or make sure that your test is actually correct. So in first case, you would want to schedule a run with regular nightly tests that are defined in Nearcore. You can do this by just calling a special Python script netdoc.py and specifying your branch and commit which you want to test. If you want to check out your new test or make sure that some test is no longer flaky like I usually do, you can run your test even several times. So you will call pretty much the same command as for regular nightly testing, but with different specification file. And that specification file can include first number of times you want to run a test. It can omit that number if it's 1, but if you want to run it several times, you can include like 1000. And expensive means that it's Rust test. PyTest means that it's PyTest. For expensive, it's kind of a weird notation. You have to specify the package of Nearcore in which the test lies. You have to specify the name of the binary which you want to produce. I assume it can be an arbitrary name. You have to specify the test and anything that you want to add to a cargo test command. For example, features nightly. And for PyTests, you just need to specify like imagine that you would call that test and specify any arguments that you want to pass. So you can use NADAC in your development. It may be useful if your feature is very big and it can touch on several different things and you are not sure that build guide tests are really covering your feature. And it can be useful if you are writing some tricky tests and want to make sure that the test will not break later for no reason. Okay. Canary nodes. Canary nodes, in terms of testing, come after NADAC. So if you remember the timeline, build guide is during your development, NADAC is night after, and canaries come like after that continuously, at least for a week before we actually release your code to testnet. Canary is a node in our production network that runs custom code, fresh code. So it is a node that works with real data, real traffic, real network, but the code can be arbitrary. We are maintaining several canary nodes in testnet and mainnet. In testnet, we are maintaining 4 of type archival, RPC, but with binary with extra assertions, and a validator node also is a canary in testnet. And in mainnet, we do not run a validator node. We do not own validators in mainnet. It's a principal thing. I don't know why, but we just don't. So we have only 3 canaries in mainnet. And you can create your own canary. It is very easy. There are instructions. They will be linked in the end. And you can create arbitrary setup if you wish to know that your feature doesn't break communication with the network, that this node will not get arbitrarily banned, isolated, it will not get out of sync with others, it will not go into some fork. If you are touching at any behavior that's gonna affect block hash or like network layer maybe, you would wanna spin up at some point canary node and make sure that it works. Betanet. Okay. For canary node, you shouldn't run it for weeks like we do. It is our protocol that we want to test code for at least a week before releasing it. It's extra precaution, but for you, it can be whatever your test calls for. If you know that your code either will not break or will break on the first block, then run it for several blocks. If you have like something concerning epoch boundaries or protocol versions, run for at least 1-2 epochs. Usually, the trickiest cases are epoch switches, so start somewhere before an epoch switches and end somewhere after, and it should be okay, like the general rule of thumb. So it can be just few hours, but it's not like a few hours of you monitoring heavily logs. You set up the node, and in a few hours you return and make sure that it didn't crash.
Okay, I have another question. Is there a way to simulate epoch change faster than waiting for half a day?
In testnet and mainnet, no, because it is not controlled by you. But in next topic, yes.
Okay.
So, Betternet and Mocknet. Betternet is a network of 10 nodes, all of which run the latest code. And Mocknet is kind of arbitrary way of defining any network that runs custom code, that is isolated over production networks, that runs on a custom number of nodes, so everything is custom. Even your traffic is defined by you. There are no limits besides your imagination and your willingness to tediously code every case of transaction you want to send to your network and at what intervals you want to do this. We have some scripts that do it automatically, but they may not cover your specific cases. Mocknet, we spin up on demand. Betternet is running continuously and is updating every day. And Betternet, as you may have noticed, is a type of Mocknet. So in Mocknet environment, you can control everything, including Genesis file. And Genesis file controls the length of an epoch. So you can create arbitrary network with arbitrary number of shards even. And arbitrary settings, configurations to stress test your code. And again, it may be a lot of work, but you probably can do anything. Okay, now to touch on the release. As I said, we use 3 different meanings for the word release. Release as act of making a release is an act of assigning specific commit a GitHub tag. So release as an object is just a reference to a commit in GitHub. That's it. Cutting the release is an act of creating a branch from master. So it's an act of creating a point in time after which we say, okay, we do not automatically accept any new changes. And publishing the release is creating a tag to that latest commit in that selected branch, and also notifying people, making, publishing some binaries, whatever else is required by infrastructure, but the minimum required action is to create a tag to some branch. And release binaries can be found in this path in S3. As I previously explained, releasing a binary is just creating a branch, a subdirectory in S3 with the name of the branch. And name of the release branch is version of the release. So for example, right now we are on 132.0. And that's it. There is nothing else to talk about the release. So let's cover what you should know. Generally, you should know that in terms of complexity, coverage, and flakiness, it all goes like this. Unit tests, then Rust integration tests, then PyTests that spins a local net, then canary node and mocknet. They are kind of different cases. You cannot really compare them. As I said, canary node is using real data and real traffic. It's just using some other code. And mocknet creates arbitrary conditions, which we can fully control. And in terms of complexity, it is easier to write and execute unit tests than it is to write and execute Rust integration test, and so on. It is extremely difficult to write a good mocknet test. That is why you shouldn't know how to do that. If you ever find yourself in need of mocknet test, you should immediately contact Node team and dump all of the information that you know, all of the requirements, and we will assist you however we can. For example, we have several mocknet tests already created. So we have mocknet test for release, as I mentioned, that checks upgradability, basically. We are creating a network that operates on the latest release. And then we gradually update nodes in batches to the newest version of release and making sure that nothing breaks. Also, we have several versions of transactions that we can send to that mocknet test. So we can send fully synthetic transactions that cover basic transaction types, or we can somehow mirror mainnet or testnet real traffic. And it takes a lot of time to set this up because of computational complexity, I suppose. I don't really know, but it takes a lot of time, like a day, to set it up. But it is very useful in case you're introducing like a major change. And if you're doing some risky protocol upgrade, you should definitely consider doing mocknet tests before your feature goes to the release stages. Okay. So what you should know in terms of technology. Build guide is a quick way to run basic tests, quicker than running them yourself. NADAC can be used for expensive tests or repeated test runs. So either to make sure that your big feature is okay, or to make sure that your big test is okay. The binary you're looking for is probably in S3, and if it's not, it is easy to put it there. And you can run your own canary node, so you can test your code on real data. It is easy and it is fast. You also can run your own separate network that is not local net, that is more sophisticated, that does whatever you want automatically. It's a matter of code, it is a matter of effort, and we are not given any specific instructions on that other than basic instruction on how to run mocknet test for the release, because there are no silver bullets, because it's such a powerful, hard, and vast tool. So, final table. If you want a build guide test, just push your code. If you want a build guide binary build, either merge it into master or manually trigger the build from build guide interface. If you want an ADAC test run, push your code and then schedule a run. There is a documentation. I will send this presentation into protocol team Slack. For local net test, try to copy something already written in PyTest directory. Anything that uses the function start cluster is probably a good template for what you want to do. For canary nodes, there is a documentation called Go Own Mainnet to create your own mainnet or testnet canary node. If you find that something breaks, that something doesn't work, contact Node team. We will be happy to help. And for mocknet test, just contact Node team, and we will help you get rid of that idea. Okay, I have a lot of time left, and I can talk about a lot of stuff, but it's better if you have questions.
I do have one question.
Mm-hmm.
You mentioned the release mocknet tests,
Mm-hmm.
that we run a mocknet with a few nodes and then test that we can upgrade from one version to the target version. Do we run this continuously, or it's something that we have to run manually?
We have to run it manually. We run it whenever we want to make a release. We run it manually because, first of all, it is expensive. And just having, we're creating a network of 100 nodes, I think, or 200. So a lot of nodes. And just having those instances in Google Cloud, and some of them with pretty big databases, is expensive.
Okay.
Oh, yeah. Betternet is less expensive type of test because we don't have real traffic there. All of the traffic is synthetic, and databases are smaller. The small number of accounts, like way smaller, I think around 200 accounts total. And we just endlessly send the same types of transactions there. And Betternet is only 10 nodes with a small state. So we run this continuously. Betternet is always operational, and we are updating code there every day. Updating the code is not the hard part, it's fully automated. I didn't cover that tool here because you probably don't need it, but we have a tool to update nodes in mass. I just wanted to clarify some points. So I want to talk more about localnet tests in PyTests, and mocknet is definitely an interesting topic in canaries. So mocknet, if you want to at some point create a very specific conditions for your test, so kind of stress test your code, you should be thinking about mocknet. You should be thinking about creating a lot of shards or a lot of transactions or very short epochs. We can manipulate all of that and stress test your code on those assumptions with mocknet. Why uh, can't you do that with other tests? So you cannot do that with Rust test because Rust test is definitely not suitable for a lot of validators, a lot of clients with different types of databases where you can control everything. It is mostly suitable for kind of like one client tests, maybe two validators tests. LocalNet is a good example of creating, again, LocalNet is a type of mocknet. It is a separate network with arbitrary code, with arbitrary configurations. But LocalNet is fully run on one machine. And that means that it has limits to how many nodes we can run simultaneously. So you cannot create LocalNet with 100 nodes. You will have to do some Google Cloud magic for that, some distributed system, and we already have like mocknet setup. So you would want to use mocknet setup to create big nodes. So on LocalNet, you cannot test 100 shards. But in Google Cloud, with a specific mocknet, you can test 100 shards. It will be expensive though. And if you want real data on your local net, even if you want just 4 nodes, it is hard to do on your machine to create 4 databases. Maybe it will be hard because of space, maybe it will be hard because of speed, but it still will be a bad and inconsistent test, and we don't want you, and it is hard to spin up. So again, if you want big state in any sense, if you want a lot of nodes, if you want a lot of space for database, you want to think about mocknet rather than localnet test. But usually you don't want that. Usually you want to test some simple behavior that is easily reproducible in small networks. So for example, what happens if one node upgrades, what happens during database migration, what happens if we kill 33% of validators. it is easily reproducible with small networks, and it is even more prominent with smaller networks. Problems of LocalNet is that those tests, LocalNet and MockNet, that those tests are flaky. LocalNet tests are mostly flaky because we want to run them fast, and we want to make them as small as possible. That means that any arbitrary mistake in synchronization, any arbitrary mistake in delay in starting up one node messes up the whole test. So those tests can be incredibly unstable. But I think it was fixed like a month ago to a more stable version. Now we're all better. Still, you have to think about synchronization, and you have to think about not assuming too much. For mocknet tests, you need to be aware that there's a lot that can go wrong with a node during like 24-hour span, and it may not be related to your code. So if every node crashes, sure, that is probably your feature. But if one node crashes, it may be something that is completely unrelated to any of your developments.
I have a question about
Yes.
this mocknet test. Where do I see the log and what's happening to the mocknet, to my mocknet?
So mocknet test is just spinning up a bunch of instances in Google Cloud and communicating with them by sending transactions and running scripts on them with various technologies, but just running scripts on them will work in this context. So every node is a separate instance in Google Cloud in a separate project, and you will be able to access any specific node and just look at the logs as you would for any other node that you're running. So it is as close to real life example as possible. It is just a separate network. So it is close in the way that we run it. It is close in the way that we execute it and monitor it, but it has different configurations for the network itself.
Okay.
Okay, I should probably stop blabbing about mocknet. If I want you to remember anything from this is that existence of this table, and it is mostly aimed at people who are only starting working at Pagoda and working in Nearcore. If you are more advanced, you may be only interested in existence of mocknet tests and their ability to mirror real-life traffic. And if you ever think about stress testing your code on a lot of machines and making sure that productivity, like blocks per second, do not drop, mocknet is the way to go. Okay. If there are no more questions, I think we can take.
Yeah, I have a question.
Yeah.
So, is there a way to, let's say, for example, if I want to shut down a node on the mocknet and then send some commands to that node and then restart, can I do it on the mocknet?
Yes, you can run arbitrary commands as user of the nodes on mocknet too. Again, it's just code. It's just I don't know how specifically it is implemented, but Google Cloud has capabilities to run arbitrary commands from users that you authenticated on the machine, just from your machine. So you can write like Google Cloud executes and like whatever you want to execute, like stop near D, and it will stop near D. And
Got it.
Yeah, sure. So you can do whatever you want in parts of update of running code, in part of configuring, and also as sending transaction to whatever node you want and however you want. It is complete creative freedom. You should think about it as just another network where you control everything from the start. Okay, any more questions? No? Okay. Then thank you for watching, like and subscribe, and yeah, see you around.
See you.
Thanks, Polina.
Thank
That was
you.
awesome.
Thank you.